So let's now try to answer this sample problem related to the balance condition. Question asks us to determine the balance compressive force PB, then determine EB and MB for the section shown in the figure, given FC prime for KSI, FY 60 KSI. Okay. So we are given this section. Actually, ito lang yung given. Sama lang natin yung ibang figure dito. So ito lang given, we are given a column 14 inches by 22 inches. Tapos meron siyang apat na number 9 on both sides. And then given na rin yung plastic centroid, although kahit hindi naman given yung plastic centroid, we can easily see na yung plastic centroid coincides with the centroid of the section. Kasi nga, regular yung shape, tapos symmetrical pa yung reinforcements niya. So most probably, gitna lang talaga yung location ng plastic centroid niya. Okay, so we are given, we are tasked to compute for the balance sa load, centricity, and moment. So we have to navigate with respect sa balance condition. So ano ba yung balance condition? So as I mentioned a while ago, balance condition is the condition that exists when a load PB loaded or located at a certain eccentricity from the plastic centroid produces a strain equal to 0.003 dun sa concrete at the same time as the extreme tension reinforcement experiences a yield strain equal to Fy over Es, wherein in this case, yung Fy natin is 60 KSI and then yung Es natin is 29,000 KSI. So if you will try to compute for that yield strain, that is just equal to 0.00207. Okay? So dito tayo mag-iikot ngayon sa condition na to. Okay? What must be this force? Itong force na to. Take note yung force natin na PB, kung tinitignan natin siya dito, ang itsura niya na lang ay parang point na lang. Okay? Kasi sa top view natin siya tinitignan. Pero kung titignan natin siya sa side view, ito siya. Ito si PB. Okay? So ano yung PB na yan that will produce this variation of strain dito sa column section natin. Okay? So first things first, na-compute na natin yung yield strain, 0.00207. So if ever that we will try to compute for the strength reduction factor, yung phi, most probably yung phi natin is just equal to 0.65 compression controlled. Bakit? Kasi di ba nga, if you can remember, masasabi natin na compression controlled siya if yung yield strain niya or yung tensile strain niya, which is in this case yung equal sa yield strain, is greater than or equal sa 0.002. Okay? So ito, greater than naman siya obviously. So most probably, papasok siya dun sa case kung saan, ito, yan, most probably papasok siya dito sa compression control. Okay? So since 60 KSI yan, according to the code, we can just take yung yields, we can just take yung tensile strain niya as simply 0.002, according to the code, instead of taking it as 0.00207 na lang. Okay? But if you want to be exact, pwede mo naman siyang ipasok sa transition kasi nandito banda yung yung 0.00207. Pwede mo naman siya ipasok sa sa transition region na lang. Okay, pero for simplicity, kahit 0.65 na lang, kahit sa compression control. Anyway, di naman yun yung tinatanong dito sa question. We're being tasked to compute for PB, EB, and MP. Okay? So, what we need to do here first is to compute this location. Nasaan tong location ng neutral axis natin. Okay? So, take note, magkaiba yung plastic centroid tsaka neutral axis ha. Baka nalilito na kayo. Okay. So, yung neutral axis na yan, we define that as C. Pero since balance condition ngayon kailangan natin, we will just call that CB. So, how do we compute that sa CB? You can just refer dito sa diagram na to, mag-ratio and proportion na lang kayo. Kahit sabihin na lang natin na CB over CB over 0.003, pwedeng ganyan. Kahit mag-ratio and proportion na lang kayo. Tapos, this distance, what is that distance? That is just, if this is D na given, that will be D minus C. Or pwedeng yung buo na lang para madali. Buong triangle na lang. We can just use the whole triangle, yung big triangle. So that will be D over 0.00207 or gawin natin general. Gamitin natin yung Fy over Es plus 0.003. Pwedeng ganyan yung gamitin nyo to get CB. Or pwede rin naman yung na-derive na lang natin na formula a while ago kasi pares lang din naman lalabas dyan. CB is just equal to 87 since naka-US customary units tayo. So don't be confused. Dapat well-rounded lang kayo sa both system of units. Times D or simply DT na lang. DT talaga yung kailangan natin, yung sa extreme. Okay. Pwede yan na lang yung gamitin natin na formula for computing CB. So substitute na lang natin. Ang Fy natin ay 60. Ang DT natin, which is just equal to D, ay given na ito, 19.5 inches. So take note lang dapat consistent yung units natin. Okay. So if we will try to solve for that, 87 over 87 plus 60 times 19.5, that will be 11.54 inches as given here. So meaning, dyan located yung neutral axis ng strain diagram natin. Okay. After getting that, ba't ba natin kailangan kunin yung CB na yan? Para makuha natin yung depth of compression block, yung AB. And since we know that A is just equal to beta 1C, wherein yung A natin will now be called A balance kasi nga nasa balance condition tayo. Ang beta 1 natin, since we are given na 4 KSI, so pasok pa tayo dun sa 0.85 na limits for beta 1. And then yung C natin will now be the C balance, which is 11.54. So with that, ang depth of compression block natin will now be equal to 9.81. 9.81 inches as given here. Okay. Bakit ba natin kailangan yung mga values na yan? Kailangan din natin yan to check whether the compression still yields or not. Yung tension steel natin, which are this, obviously nag-yield kasi nga, we are assuming the balance condition wherein nag-yield nga siya So, hindi lang natin alam kung yung mga compression steel natin, kung nag-yield ba yan or not. So, how do we get that? How do we know kung nag-yield siya or not? We can just simply compute for this, just like what we do sa beam. We can just compute for strain S. Okay? So, may formula na tayo dun for strain S prime. Strain S prime yun It is just equal to 0.003 times C minus D prime over C. Yan yung general formula natin. Although in this case, since balance condition tayo, yung C natin, papalitan lang natin ng CB. Okay? So, let us just change them. Yung C natin, dalawa, that will be 11.54. 11.54. Ang D prime natin, according dito sa problem, ang D prime natin is this distance from the compression reinforcement to the extreme compression fiber. That is just equal to 2.5 inches. Puro inches yan lahat. So, for that, 0.003 times 11.54 minus 2.5 over 11.54. 0.54. Ang lalabas na strain S natin is 0.00235. So, yan yung strain. Yan yung strain ng compression reinforcement natin na 'to. And if we will try to compare that sa strain Y, that is obviously greater than strain Y, which is 0.00207 or kahit 0.002 na lang. Kahit alamin na natin yung exact. So, with that, we can easily see that the compression steel yields. Nag-yield siya. Okay? So, ano bang importance nun? Ba't ba natin inaalam kung compression steel yields or not? Kasi kailangan nating malaman yun to know kung ano yung ba yung gagamitin natin na Fs prime. Okay? Or yung stress acting on the compression steel. Kasi kung yung Fs prime ay less than Fy, we have to find that exact value. Okay? Kung greater than Fy naman yung Fs prime, we can just simply use Fy. Okay? So, like here, nakita natin, Fs prime is greater than Fy. Therefore, we will just limit our Fs prime to Fy. Fy lang yung gagamitin natin for computing the force acting on the compression reinforcement or yung sa CS. Okay? So with that, we can now compute for each of the forces acting here. Ito, yung CS, yung CC, tsaka yung T. Lagi naman yung apat na magkakapartner plus yung PP. Okay? So isa-isay muna natin. Let's start with CC. Let's compute for CC, yung force acting dito sa compression block. So that is just equal to 0.85 FC prime times the depth of the compression block, AB, yung A na balance, since we are talking about balance condition, times the width, B. Okay? Substitute na corresponding values, 0.85, FC prime natin ay 4, ang AB natin, na-compute na natin, ay 0.81. Ang B natin, yung width ng section natin, 14. So that is just equal to 0.85 times 4 times 9.81 times 14. That will just be equal to 466.95 or simply 467 na lang. 467 kips. Okay. And then next is yung T, yung tension force. That is just equal to AS Fy. Wherein yung AS natin, since number 9 na ano na naman, na reinforcement na naman, alam na natin yung area ng isang number 9 na reinforcement, that is just equal to 1 square inches. Meron tayong 4. Ayun, nakalagay 4. So, times 4 lang natin, times Fy na 60. So, that will be 4 times 60, which will be equal to 240 kilos. Okay. And then lastly, yung CS. CS is just equal to AS prime times supposedly Fy lang. I mean, supposedly ganito yung formula niya. Fs prime minus 0.85 Fc prime, taking into consideration the effect of the compressive concrete na na-displace. Supposedly ganyan. Okay? Yung Fc prime, alam natin yung value. AS prime, compute natin kasi 4 na number 9 lang ginamit siya. So, 4 times 1 square inch lang na. Ang problema natin dyan, yung Fs prime. Okay? What is the value of Fs prime? But since na-compute na nga natin kanina na compression steel yields, therefore, alam na natin na yung Fs prime will have a value greater than Fy. And hindi naman natin ginagamit yung value greater than Fy. Nililimit lang natin yung value niyan to Fy lang. So, therefore, yung Fs prime natin dyan will just be Fy na lang. Okay? That is how we compute the value of CS. So, AS prime natin ay 1 square inch, yung area ng isang bakal, 4 siya, nakalagay dito, 4. So, times 4, times Fy na lang, which is 60, minus 0.85 ng FC prime na 4. Okay. So, computing 4 times 60 minus 0.85 times 4. That will be 226.4. 226.4 kips. Okay. So, with that, we can now compute for, or we can already use this force system to compute for the unknown values starting with PB. Okay? So computing for PB, sum up lang natin yung mga forces. So yung mga pakanan na forces ay PB plus T, and they must be balanced by CS plus CC. Okay, substitute the corresponding values. PB plus T na 240 is just equal to CS na 226.4 plus CC na 467. So, ang nawawala na lang dyan ay PB. PB is just equal to 226.4 plus 467 minus 240. PB is just equal to 453.4 kips. Okay, that is the first answer dito sa problem natin. So, yung magnitude ng load that will produce a balance condition is equal to 453.4 kips. Okay? But hindi pa diyan nagtatapos yung natin, yung computation natin. We also have to compute for the eccentricity tsaka yung bending moment. Okay? So, do we compute for, we can start computing for AB. So, computing for EB, we can just take moments about the plastic centroid. So, i-moment lang natin lahat ng mga force na yan with respect dito sa plastic centroid. Okay? So, we can just moment PB. Ang distance ng PB sa plastic centroid, we already know that. That is just the eccentricity. But since we are talking about the balance condition, lagyan lang natin siya ng subscript na B. Okay? So, clockwise moments yon. So, kailangan siyang i-balance itong mga counterclockwise moments coming from CS, CC, tsaka T. Okay? Let's start with, let's start with CS na lang. CS, ang moment arm niya is, since yung plastic centroid ay nasa gitna, that is just 11. Okay. So 11 lang yon minus D prime na 2.5. Yan yung moment arm niya. Plus CC, ang moment arm niya will be 11 ulit minus half ng AB. AB over 2. Okay? 11. And then, yung T naman, ang moment arm niya will be, actually, ganun pa rin, 11 minus 2.5 lang din. Okay? So, substitute na lang natin yung mga corresponding values nila. PB is 453.4. CS 226.4. CC 467. Ang AB natin, na-compute na natin kanina, that is 9.81. Ang T, 240. So, ang unknown na lang diyan ay EB. We can directly compute for EB. EB is just equal to 6.4, 11 minus 2.5 plus 467 times 11 minus 9.81 over 2 plus 240, 11 minus 2.5 divided by 453.4. So, EB will be approximately 15 inches. Okay? EB is approximately 15 inches, and that will be the another answer for this problem. Box na lang natin. Okay? And then lastly, we will compute for MB. So how do we compute for MB? Since we already know, so ako na lang lagay, computing for MB, the balance moment. Since we know that the balance, or since we know that P is just equal to, M. It must be M. Since we know that M is just equal to P times E, and since we are talking about balance condition, lagyan lang natin ng mga subscript na P, lahat to. We can just simply substitute the corresponding values. We can simply substitute values of PB, which is 453.4, as well as EB na 15 inches. In that way, we can easily compute for the balance moment. And that will just be equal to 453.4 kips times 15 inches. So that will just be equal to 6801 kip inch. Kip inch. 453.4 times 15 niya. 6801. Or kung gusto natin siyang gawing kip feet, we can just divide it by 12. So that will be equal to 5, 6, mga nasa 5, 6, 7 kip feet. Okay. So that will be the last answer for this problem. So either of the two na lang. Kahit ito na lang. Para naka-keep fit. Okay. So, ibig sabihin lang nito guys, for a balance condition to happen, para yung concrete maka-experience siya ng 0.003 strain at the same time na yung tension reinforcement ng column maka-experience ng strain equal to the yield strain. Para mangyari yan, we have to apply a load equal to 453.4 kips at a distance or at a centricity at an eccentricity equal to 15 inches from the plastic centroid. Okay? Dapat mag-apply tayo ng load na 453.4 at a distance or at an eccentricity equal to 15 inches from the plastic centroid para mangyari yung balance condition na to. Okay? So, if that will happen, the corresponding bending moment that it will produce is equal to 567 kip feet. Okay? So, this is the balance condition for this particular problem.